Okay, in this lesson we're going to go ahead and we're going to take this square root function and we're going to sketch it. Now, we know it's a square root function just because it has the radical sign inside it. So we know that it was based on, or is based on, the parent function, which is just f at x equals square root of x. It started as that function, and then it had a whole bunch of different transformations applied to it. And we know from our lessons that this 2 out in front is a vertical stretch. The -5 on the end, well, that's a vertical translation down in this case. But what's sort of caught my attention is that inside the square root function here, it doesn't look like what we were expecting to see. Because inside the square root function, normally we're expecting to see something that looks like x and then minus p, and the x is all by itself. There's no negative sign glued onto the front of it. There's no, value like a 2 or a half or a third or 8 in front of it. It's just x all by itself. So we can clearly see that the negative x plus 1 just needs a little bit of fixing, and then we can clearly pull off all the transformations. So let's just continue on, and we're going to go ahead and rewrite this equation. And the only thing I'm going to do to the inside is I'm going to factor out that negative sign. Okay? So I'm going to factor out the negative, and what that's going to leave me is x, and notice that the positive one is going to flip to a -1. And we still have the -5 at the end. Now, this looks like we're expecting it. Okay? We clearly have a vertical stretch of 2. We have a vertical translation down of 5. We have a horizontal translation. Remember, inside associated with the x, it's opposite of what you would think it is. So this looks like -1, which you would expect to go to the left, but we're going to the right by 1. Okay? And then this negative sign here, well, what is that doing? Well, that is going to be a horizontal mirror of the function, which means it's going to be reflected in the y-axis, and we'll show you how that gets applied. Okay? So we just had to do a little bit of factoring to make this look as we expect it to, and then we can clearly pull off the transformations. So how do we go ahead and sketch this? Well, let's just pull up a little piece of graph paper here, and we'll do a little bit of sketching. But before we get started, why don't we put in the original parent function? Because we can use that as a reference point to help us decide where we should be when we sketch this transformed function. So the square root function, if you remember, it starts out at 0, 0. Okay, so I'm just going to put a dot here at 0, 0. So there it is. The next point is at 1, 1, because the square root of 1 is 1. And the last point is at 4 and 2, because the square root of 4 is positive 2. Now, that means that the parent function opens up and to the right and continues on like that. And that is the square root function. That's what we're used to seeing. Well, how does this transform function look? Well, to find out where we need to graph this, here's where we're going to start. We're going to start with the anchor point. And the anchor point is this 0, 0 right there. And an interesting thing happens with this anchor point, because we know if we were working with a table of values, we would always apply the vertical and the horizontal stretches before we apply the translations. So just bedmass would tell us that we do multiplication before we do addition and subtraction. So in the x and the y direction, we would always multiply the vertical and horizontal stretches and compressions first. Well, if we take this point and it happens to be 0, 0, it doesn't matter if I multiply it by 2, I'm still at 0, 0. And it doesn't matter if I apply a reflection in this case, I'm still at 0, 0. So we can just apply these red transformations to the anchor point and move it to where the new function will start. So let's move it over 1 and down 5. So over 1, down 5, put a dot right there, and we've got our new starting anchor point. Okay, well, how do we put these other 2 points in? Well, let's just look at the stepping pattern that the square root function had. From the anchor point, it normally went up 1 and over 1, which means from here, we would expect to go up 1 and over 1. But we're not going to do that. And why not? Well, take a look here. We've got a vertical stretch of 2, which means our up 1 is no longer up 1, it's up 2. Also, look inside the square root for the horizontal stretch or compression. Well, we don't have a stretch or compression because we've got a 1 there and that doesn't change the shape, but we do have a horizontal reflection. So instead of going to the right, I'm going to go to the left. I'm going to expect this function to start here and go in this direction instead of to the right. Okay, so let's go ahead and put in our second point. And what we do is from our anchor point here, normally we would have gone up 1. Because of the vertical stretch, we're going to go up 2. And then normally we would have gone to the right 1, but because of the reflection, we're going to go to the left 1. And there's our second point. Okay, well, how do we get the third point? Well, pretty easy. If I consider back from the anchor point that I went up 1, 2, and then over 1, 2, 3, 4, from this anchor point, instead of going up 2, I'm going to go up 4 because of that vertical stretch. So I'll go up 1, 2, 3, 4, and now which way do I go on the horizontal? Well, because of the mirroring, the reflection, I'm going to go to the left, and there's no stretch or compression, so I'm just going to take the regular old step that I would, which would be 4. So 1, 2, 3, 4. And I'm going to put a dot right there. Okay, so there is the new function sketched. It starts here and carries on that way. All right, well, how do I know I'm right? Well, we could do a little check with the table of values. We could always just take a table of values, put in the parent functions, coordinate points, and then apply the transformations to them. So let's do that really quick, just to make sure that we're on the right track here. So there's x and y. We know the parent function is anchored at 0, 0. We know it has a point 1, 1. And we know the next point is at 4 and 2. Okay, so it doesn't matter if we focus on the x or the y's first. We can do the x's. So let's start inside here. We apply the horizontal stretch or compression first, and then we apply the translation. So there is no stretch or compression. We got a 1 there, but we do have the negative sign, which means that all of these values need to be multiplied by -1 so that they are mirrored in the y-axis. So I'm going to multiply all of these values by -1, and that gives me 0, -1, and -4. Okay, the next thing I'm going to do is I'm going to take care of this horizontal translation of 1. It's to the right 1, so I'm going to add 1 to all of these x values. So let's add 1, and that gives me 1, 0, and -3. Okay, let's move on to the y values. Again, with the y values, we're going to apply the stretch before we do the move, the translation. So it's stretched by a factor of +2. So I'm going to multiply these y values by 2, and I get 0, 2, and 4. And then I'm going to go ahead and apply this vertical translation down. So I'm going to subtract 5 from each of these values, and I get -5 and -3 and -1. Okay? That means that if I look at the outermost points, the coordinate points of this new transformed function is 1, -5, and then looks like I have a point at 0, -3, and finally -3 and -1. Okay, well, let's take a peek. This point 1, -5, is that on the new function? And if I look over here, there's 1 and -5. So that first point definitely is on. Okay, it's right there. 0 and -3. Well, 0 and -3, that one checks out. That's on the function. And -3, -1, well, -1, 2, 3, and -1, well, that point's on there as well. Okay, so that's how you can quickly sketch a square root function that has many different transformations applied to it. And the biggest thing you need to do is just make sure that you move the anchor point first, and then base all of your movement off that new anchor point, and just follow the same sort of pattern that you would have with the parent function, except apply the appropriate stretches in both the or compressions in the vertical and horizontal directions. Okay.